Good morning. You are listening to Mr. Bryce Mugwe, and I'm going to tell you today about the history of life. Because life on earth as we know it today wasn't exactly the same way back then. Earth was created or was finally formed about 4 billion years ago. And a lot of things have happened on the earth such that we are able to then establish a history based on certain studies that we'll explore when we're going through this chapter here, so that we are able to establish a history of all the occurrences, all the happenings that took place on earth. This somehow links up with the theory of evolution, which is just another explanation of how life began. Because if I ask you now, how do you think life began? I know most of you, John of Bushiri or Likanya, you start telling me how in the Bible, God did this, created heaven and earth, Adam and Eve, and they did a lot of things. Today you are children of Adam and Eve and all of that. Okay, that's a biblical version of it. In this chapter, nonetheless, I would not like to interfere with any of your religious belief. So whatever I'm saying here is just for learning purpose. It's in no attempt to go against what you were taught in your different doctrines. So we're just doing learning of what happened on earth. It is believed that organisms formed from simple organic molecules. And this was due to the absence of oxygen. When the earth formed about 4 to 6, should be billions years ago, there was little or no oxygen on earth. And this absence of oxygen allowed the formation of organic molecules. I'm sure by now my students will be able to name some organic molecules. Okay, the protein and all the like. But I know the organic molecules we've explored so far contained oxygen, but these ones here had no oxygen in them. Now, prokaryotes, what are they? These are primitive organisms, primitive in the sense that they have no true nucleus. They actually have a nucleoid, and their organelles are not membrane bound like the chloroplast, if they had one, or like the mitochondria. They don't have any membrane around them. So their nucleus has no membrane as the traditional nucleus that we know with the nuclear membrane. Hence, they have just genetic material which is found at a position in their cells. The most probable position in their cells where we find this genetic material, we'll call that place the nucleoid. Hence, these organisms are called prokaryotes. One peculiar thing with prokaryotes is that they were anaerobic. It means they did not need oxygen for their activities, for example, like respiration, for their metabolic activities. Hence, they underwent anaerobic respiration because they did not need oxygen. Now, I know that we say organisms that don't need oxygen for respiration would rather think that surely they were using carbon dioxide, because for us, most of the time, by fire, by force, if it's not oxygen, it is carbon dioxide. This is not the case. If some organisms don't use oxygen for aerobic respiration, they would rather use other elements like hydrogen for anaerobic respiration. It means we say respiration is aerobic when it is using oxygen. We say respiration is anaerobic when it is not using oxygen. Whatever else it is using, as long as it's not oxygen, we say it is anaerobic. So the first organisms to develop were these prokaryotes. We developed about 3.5 billion years ago. I'm glad they put here billion, because this is supposed to be billions here. So because organisms can develop billions of years ago and then the earth itself formed just millions of years ago, that's not true. Okay, so please correct this. This should be billions, not millions. So the prokaryotes were the first organism. And these prokaryotes included bacteria, for example, the blue-green bacteria. And remember, as time went by, you'll see that we live from 4 to 3.5 to 2.5. The figure is decreasing. When this figure is decreasing, it means that the figure is coming towards present times. Because we are talking about years ago. The bigger the figure, the further back into time. The smaller the figure, the closer to present time. So that's how we will be looking at these time scales that we call the geological time scales. So we'll look at that in another video. Now, the prokaryotes that developed, like I said, included bacteria like the blue-green bacteria. And the blue-green bacteria are an example of photosynthetic bacteria because they are able to undergo photosynthesis. Why? Because they contain an organelle called the chloroplast, which contains a green pigment called chlorophyll, which is able to trap sunlight exactly like with plants, such that they start producing simple substances like glucose, which will be converted into polysaccharides like starch. It means these bacteria are able to produce their own food. Interestingly, as these bacteria produce their own food, just like plants, they use up carbon dioxide from the atmosphere. And this carbon dioxide is then used for the process of photosynthesis, which then produces or releases oxygen as a byproduct. Now, remember at the beginning we said that there was more or less little or no oxygen in the atmosphere. That means the only organisms able to be alive at this time were organisms that don't need oxygen, because organisms that need oxygen, since there's no oxygen, it is obvious they will not be present because they can't be alive if there's no oxygen. So remember carefully that in the beginning here, there was little or no oxygen. It means most organisms were either just anaerobe or non-existent. That's what it means. Now, these anaerobic bacteria, the blue-green bacteria, which were capable of photosynthesis, used carbon dioxide and released oxygen. I don't know whether you see where we are going to. For the first time, due to photosynthesis, oxygen started coming into the atmosphere, more and more oxygen. What are we going to experience? We are going to experience an increase, a slow increase in the levels of oxygen. The levels of oxygen started to increase. And what would this lead to? Now, it's freezing. Let's just wait a bit. Now, as the level of oxygen increased, remember before, when there was no oxygen, there were no organisms, aerobic organisms that were present because none of them could thrive in that kind of environment. Now that oxygen is present, what will happen? Organisms that depend on oxygen started to develop. For the first time, we started seeing aerobic organisms also coming up. It means if I should divide these organisms into two groups, I'll have group A, which are the anaerobic. The first ones that were there, they did not need oxygen, they were already present. Now, group A started photosynthesizing and produced oxygen. Now that there's oxygen in the atmosphere, what happened? The presence of oxygen allowed for the appearance of group B organisms, which are oxygen-dependent organisms. It means they are aerobic organisms. They require oxygen for respiration, which is part of their metabolic reactions that keeps them alive. Respiration is the use of, or is the oxidation of food to release energy in the form of ATP. that is used to keep your body warm, to make you do your daily activities, to keep you alive. It's that energy that provides you with fuel to stay alive. So with no fuel to stay alive, there's no life. With no respiration to produce ATP, there's no life. With no oxygen for aerobic organisms to undergo respiration to produce oxygen, to produce ATP, there's no life. So it means when oxygen came in, aerobic respiration was possible, respiration took place, ATP was produced, these organisms were able to have life. So organism B, the aerobic ones, now started appearing. And this will lead to what we call an explosion of new organisms. Okay, we'll look at that in another chapter, where we have that sudden appearance of many new life forms. So when looking at that, scientists believed that due to the lack of oxygen, some life forms developed. But now, because of the presence of oxygen, there now was a diversity of life forms. That occurred after the Cambrian explosion. We'll look at the Cambrian explosion in another chapter. What does this statement mean? Development of life, diversity of organisms. Development of life, remember at the first stage, there was just one kind of organisms. I call them organisms A. At the second stage now, there was the release of oxygen by organism A. Now there was organism B. Diversity means differences, varieties. I'm sure that when the first one, with the first organism A only, there was no variety. There was just one type. But now that organisms B popped out, now we have variety. We have diversity. That's what it means. There was some kind of diversity that occurred with the presence of oxygen. In the absence of oxygen, there was simply just development of life, but with no diversity. With the presence of oxygen, there is now diversity. Now, this means that as the level of oxygen, increased on Earth, many different types of organisms developed because they could then use oxygen for respiration. And we're also going to do photosynthesis. You will see that respiration and photosynthesis are just opposites of one another. We'll do all of that in grade 11. Now, again, as time went by, the Earth went through different geological events. For example, as these organisms were created, the Earth went through different geological events. For example, the ice ages. The ice ages were just long periods of time when the Earth experienced extreme cold. These organisms surely were not very used to the cold, but all of a sudden, the temperatures dropped drastically and went to extremes, up to a point that it led to what we call mass extinctions. I will discuss that at a later stage. Okay. Throughout the history of Earth, there was the experience of 4 ice ages. The first one occurred 700 million years ago. Remember, we're dropping from big figures to low figures. It means from far back in time to present times, the figures will be decreasing. So the first ice age occurred about 7 million years ago. The second ice age about 320 million years ago. We're dropping again. The third ice age occurred about 286 million years ago. And the fourth ice age is what we are experiencing currently. Presently, it started about 3 million years ago. And we're still experiencing the fourth ice age. Now, during these ice ages, what happened? We had large sheets of ice, big blocks of ice that we call glaciers, which formed. These glaciers formed through a process that we call glaciation. Glaciation is the process during which the large sheets of ice that we call glaciers actually formed. Now, glaciation led to sudden cooling of the earth, which led to very low temperatures. And these temperatures were extremely low. They did not support life. It means they led to the death of many life forms. This death of many life forms is what we call mass extinction. Now, extinction is the total disappearance of a particular species on Earth, or it is that time in which we cannot find a single representative of a particular species, or again, it is when the last representative member of a particular species finally dies. It means that that species went extinct. Now, there is a difference between extinction and mass extinction. Extinction is the disappearance of one species. But it so happens at a particular period in time that due to certain geological events like the Ice Age, glaciation, it so happens that many different species get extinct more or less during the same period. That's what we refer to as mass extinction. Many species went extinct, mass extinction. Now, how did the ice ages occur? Different factors led to the cause of glaciation. Some of these factors are the changing positions of the continents. In this case, we'll be looking at the movement of land masses, continental drift. I'll discuss that in my next video. The upward movement of continental blocks. This will look at the movement of plate tectonics, which rose, as it is believed, about 600 meters vertically upwards in the last 15 million years. The first one, the changing of continental positions, the continental drift, I'll look at it as a horizontal movement, separation of the continent, while the plate tectonics is a vertical movement, gaining in altitude of the continent. We'll see what it caused. Then the reduction of carbon dioxide in the atmosphere also caused mass cooling, because carbon dioxide is one of those gases that traps radiation that is supposed to leave the earth going back upwards. You should have done this when you did, surely in geography, I don't know if you've already done global warming. With global warming, the sun sends rays, heat waves to the earth. The earth gets the heat, and the earth tries also to lose the heat in an attempt to cool off. Just like you and I, if our body is too hot, our body sends out heat in the form of waves, the radiations, so that we can cool off. Now, if we are found under a blanket, in winter for example, you cover yourself with a blanket, that blanket is going to keep you warm, because under that blanket you will suddenly start seeing warmth, heat accumulating. Where did the heat come from? The heat came from your body, and since the blanket is blocking the heat from escaping, because it's made up of material which we call insulating material, which are the opposite of conducting materials, which are materials that allow heat and electricity to flow through them. With insulators, they don't allow heat and electricity to pass through. So the heat is trying to radiate from your body, but the blanket somehow blocks it. It means the heat will remain around your body. That's how you feel warm. The same happens with the earth. The earth also has a blanket around it. I'm not saying that if you look up in the sky, you might see a blanket there that maybe God is using to cover the earth. No. Okay, I'm trying to say that there is some kind of blanket around the earth, but this blanket is formed by gases. Gases that we call greenhouse gases. One of such greenhouse gases, the most prominent one, is carbon dioxide. So when carbon dioxide accumulates in the atmosphere, it forms a kind of layer. It forms a kind of layer around the earth. Okay, so that layer around the earth is like a blanket. We call that effect a blanketing effect. Now, with that layer around the earth, it's not possible, it's not very easy, because the sun heat sends heat waves down to the earth, and the earth tries to cool off. When it tries to cool off, it has to send back heat waves up, radiation. If there's no layer, then the heat will escape and the earth will remain very, very cold. So to avoid that, that's why we are lucky enough to have carbon dioxide and other gases like methane and water vapor that act as greenhouse gases. The space that is formed around the earth, that space inside the blanket, is what we call the greenhouse. That's why we call these ones the gases, the greenhouse gases. And the kind of blanket that they form is what we call the blanketing effect. Okay, so I was saying, if there's carbon dioxide now, the heat cannot easily escape. When the heat goes up, it will bounce on this blanket and come back towards the earth, bounce and come back, such that around here now the temperature is warm. What does it tell us? If we now remove the blanket, the carbon dioxide, the heat will escape back. The earth will remain very cold. It means that a reduction in carbon dioxide in the atmosphere will lead to what? Glaciation. Will lead to glaciation because of extreme cold. Okay? So, but then the problem we are facing today with global warming is that this blanket is becoming more and more thick. If you are having a more and more thick blanket over you in summer, what will happen? You will sweat too much, even up to the level that they will think you are a goat sweating. Understand? So, because the temperature is too hot. So if this blanket around the earth is also getting too much, how does it get too much? It will get too much if these gases accumulate more. So when the gases accumulate more, how does it happen? More carbon dioxide present in the atmosphere, more methane, more water vapor. If you look at carbon dioxide, why is it accumulating too much in the atmosphere? Because we are burning fossil fuels, petrol from cars, the carbon dioxide that they produce from the exhaust pipes. We are burning coal. Some of you like drying too much. You don't want to waste any time with dry. Even if you don't have money, you go and participate and look for friends who have money, and then they'll dry for you. Okay. So when you are burning coal, when we are using coal to generate electricity, especially the case with South Africa, most of our electricity comes from the burning of coal. So if you want electricity in your houses, I want also, he wants, they want, all of us, if we keep on using too much electricity, it means that somehow we are asking someone somewhere to burn more coal, to produce more electricity that can satisfy all of us. So the more coal that person will be burning, the more carbon dioxide will be released in the atmosphere. There are many of such things that release carbon dioxide in the atmosphere. Now, too much carbon dioxide in the atmosphere also is not good. To some level, carbon dioxide is good so that it can prevent glaciation. Okay? But when now it becomes too much radiation will be accumulated around the earth will become too hot, and this is what leads to global warming. The average temperature of the earth is increased, and then it will now lead to environmental catastrophes like changes in climate, like melting of ice around the poles, melting of ice caps at the tops of mountains, which will lead to floods. Imagine there's an ice cap at the top of a mountain, and then it melts. When it melts, it represents oceans of water that's flowing. A huge iceberg, for example, represents oceans worth of water, or lakes worth of water. Imagine all this water flowing down to human settlements. It will cause floodings. Global warming will also cause evaporation, too much evaporation from the earth, from the ground surface, from the water bodies, and it will go up into the sky. It will condense and precipitate. Too much rainfall again will lead to rains. Rising temperatures will cause changing levels of pressure of gases that are rising too quickly. their pressure levels are changing too fast, leading to heavy to large winds like hurricanes or cyclones. All of these are just natural catastrophes. Included too also is the presence of bushfires. Forests that just catch up fire on their own. Not that someone, maybe one of you were smoking, maybe it's Nyaope or something like that, you throw your cigarette in the forest and it started burning. No, a forest can even on its own, especially we see it in the dry savannas, where the bushes catch fire on their own because of extreme heat. So carbon dioxide is good, yes, to prevent glaciation, but if it accumulates too much, then we start having the negative impact of global warming. Okay, for this section, this will be the end for this first video. Otherwise, we'll get too heavy. I'll send further videos as part 2. Thank you very much for attending.